we want to integrate tan theta with respect to theta. This is the integral of sine theta over cos theta d theta. Note here that if we take cos theta and we differentiate, we get minus sine theta. So apart from the negative sign, the top of this fraction is the differential of the bottom. If we think back to our differentiation, if we had the log of cos theta and we differentiated, we get 1 over cos theta multiplied by the differential of the inside function. And this gives us minus sine theta over cos theta, which is minus tan theta. It follows that if this is minus tan theta, integrating would give us log cos theta. Differentiation and integration are reverse processes. So if we're integrating tan theta instead of negative tan theta, we should get minus log cos theta. Using our log laws, the negative can go inside, like so, and this gives us log of sec theta plus a constant. Remember, 1 over cos theta is sec theta. Once again, you wouldn't necessarily be expected to spot all of this, although if you're familiar enough with your differentiation, you really ought to be able to. Once again, a method we'll meet later, called substitution, can help us do this sort of integral.